All right, so today I will talk about the sovereignists in the room versus the globalists. And I think this is what most people actually get wrong about this space. And it will hopefully become clear to you why that is, and another perspective that we should be thinking about when we think about what kind of infrastructure and what kind of tooling we're actually building. So this isn't about better decentralization or better privacy or better global DA. Those help, but they aren't enough. This is about an ethos that we should be following when building our systems. And like, I'll start with maybe one or two examples here, which is if you are building an application in the space and like the first thing on your website is your very nice SDK documentation, like you're probably building the wrong thing. This very much most likely means that you're building a Web 2 service that you expect someone to hit your server for, right? Like if this fundamentally relies on you running a bunch of infrastructure that everyone in the room relies on, whether it's custodial or non-custodial doesn't actually matter. But like if you're the single entry point, you are building something that's closer to Web 2 than to Web 3. The other thing is, our goal is to build sovereign infrastructure. And actually, I think as a goal, this is much better than saying we want to build decentralized infrastructure or we want to build private infrastructure. Because everything always depends on context. For example, there is no compliant privacy. I mean, this is like, it's an oxymoron because you must define under which specific real-world model are you compliant. You most likely cannot be both compliant with the US government, the Swiss government, and the Chinese government. Just think about this in the context of tornado cache or privacy pools. You must pick a specific block list that you are using. Which means we should be building many systems that can be interoperable with each other so that everyone individually can make their own choices on whether they want to be compliant with the OFAC list, or I assume the Chinese government must publish a similar style list, right? Like, so it always depends on context. There is no, and so every time I read someone is building a compliant privacy system, I'm like, cool. What you most likely mean is you're building a US government compliant privacy system, which is not inherently bad. It's just very specific that privacy depends on context, or compliancy depends on context. Another example here is actually identity. Identity very much depends on context. I think what most people in this room take as identity, most likely, is sort of national identity, passports, ID cards, right? But they represent a very specific snapshot of an identity. If you actually want to do, for example, get a much better identity for me, the right person to ask isn't the German government, it's like my kindergartner or my grandma's friends. They have a much better sort of notion of who I am as a real person than a specific passport can give you, right? So identity really, again, is very context dependent. Right. Sorry, I need to point towards you, yes. All right, the space, so the goal of the space is to be sovereign. And if the clicker doesn't work because it's not on, press harder. No, not harder pressing. Anyway, if you just jump like 2 slides forward, I think, because, okay, one back. I went to that slide, the red one. So the goal of the space is to be sovereign, and a single decentralized network is still very much centralized. And actually, I'd like to start with sort of a survey here. Who here thinks that a one-world government is a good idea? Yes, see, this is always what happens. So no one ever says that a one-world government is a good idea, but building a single centralized thing is very similar, even if that thing is decentralized, because anything that is a single entity can become compromised either due to technical reasons or social reasons, whatever you have. So you never want to have a single thing of something. You always want to have many similar things so that you can effectively vote with your feet and exit. This is, I think, why most people don't really like the idea of a single one-world government, because I think in the back of our minds, we always have this idea that, you know, if shit hits the fan where you currently live, there's always other places that go to that aren't exactly the same. And so we should also not just design a single global decentralized system, but rather many globally decentralized systems or many global interoperable systems that sort of work within the specific context where where specific people want them to work. So a single decentralized network is still very centralized. Sort of as a quick TLDR, and I think a bunch of people will be very unhappy with the statement, but from a physical perspective, I give Bitcoin and Ethereum like a 0% chance to survive World War III. Because most likely, communications bandwidth is going to be incredibly scarce, and the first obvious targets in any sort of large-scale altercations are going to be fiber optics cables, followed by satellites. And so the remaining bandwidth that is going to be available, which it's not going to be zero, some telegraph lines will still be fine, will most likely not be dedicated towards our magic internet money and getting to global consensus on them. So from a physical perspective, a single decentralized system doesn't actually solve really our problem. It just means that we are now brittle. And in a previous talk, we actually spoke about this brittleness, that you want to have resilient systems. From a social perspective, they can easily be captured. Normally, I give this example of Bitcoin, which I think a bunch of people will also not like. But to me, Bitcoin became captured because at least the idea of it needed to evolve over time. Like, technology is never going to be stagnant, so you want to have an asset that may have some specific characteristics, but you want to keep evolving the base layer technology or the utility of what you can do with that asset. And yeah, as the survey showed, we shouldn't design blockchains like a single one world government, because apparently no one in this room actually does like the one world government option. Yeah, so a single security instance can extract rent, it can harm users. You always must give users the ability to leave. And here actually, or you must give users a credible threat. And I'll use the example of Switzerland here, which is that if you ever come to Switzerland, let me know. It's a beautiful place, which does some funky things, such as 2 cantons still do public hand signal voting. And it's not a secret ballot. It just, once a year, everyone in the canton, everyone that has voting rights there, meets up in their local town square, and then they stand around in a big town square, and then they decide on the tax rate for the next year by a public hand vote. And the best part of this is they don't count. There's a guy on top of a tower in the middle, and he estimates. And he goes like, the ayes have it, or the nays have it. And it gets even better, because when the guy isn't certain, he just gets 4 more people on top of the tower. And then whatever those 4 more people say, like whatever the consensus is between the 5, is what the vote is. And this also, I mean, there's like some technical reasons for why this is the case, like you can always enter and leave. But it's also, due to having a public voting system in this case, it's actually very, very difficult to corrupt. It is much easier to corrupt a secret voting system than, for example, this kind of voting system, because you cannot obviously miscount, right? Like everyone, some people come up to me and go like, well, what if the guy goes 90% vote yes and 10% vote no, and he still says the no's win? The guy gets chased out of town. Like, there's a credible threat here that like keeps the system stable. And the nice thing is also that these votes happen once a year, and you can recall your government in them. So the population actually has a very credible threat to keep the system stable, because they can't do vastly unpopular things, because they know they will get recalled within sort of 6 to 9 months via a public vote. And on top of this, you also have referendums. Next one. Oh, this actually may have worked now. So also different people want different security models. And I think the best example is, I keep thinking of my parents here, which is, my parents will never trust global Ethereum. There's no amount of money or education you can do in the world to convince them that global Ethereum is more secure than their local government. This may not be true for everyone, that's obvious. Like if you live in Argentina, I totally understand why you trust global Ethereum more than you may trust your local government. But fundamentally, different people have different preferences with regards to their security model. And this is fine. Like, we should be supporting this kind of idea, because it actually gives us in-depth resilience. It doesn't require that we must all globally agree on a single security model. It means that different people can choose. And as long as those different systems have a homogeneous architecture between them, actually moving between those security models is very, very easy. By the way, as an aside, this is also, I think, why there is a sort of much larger traction in the non-NATO Western world with regards to adoption, because people generally don't trust their government as much. So like if you live in Turkey, it may make a lot of sense to hold a lot of your assets on global Ethereum. If you live in Germany or Switzerland, like you trust your local banks, you trust your local jurisdiction, your local court system, right? So fundamentally, different people want different security models. So my parents want something like local government, Argentinians may want a global government. The really important thing is that this sounds really good theory, but when we built this, we need to really be careful about not splitting the UX. And another good example here is phones. The nice thing is I can use my phone that I bought in New York, in Switzerland, as well as in Thailand, because we've sort of magically agreed upon decent baseline standards for wireless communication, which allows my phone to roam across all these different specific security instances, right? And this is also really going to be the trick here, that we want to have infrastructure, we want to have protocols that allow us to have a homogeneous application architecture that can be deployed in many different environments, so that where it's very important that users don't have to sort of like point to new RPC or like download a new node software to do it, but rather can define in code, I would like to get my intent settled on Ethereum, or tomorrow I'd like to get it settled on Solana, or the next day I'd like to get it settled on global Anoma. This is sort of really the fundamentally important thing here, that users and applications can easily roam. This doesn't help if we have just 500 independent, incompatible systems that now I have to carry around 500 phones because we couldn't agree on a global telecommunications standard. Which brings me to sort of the second part of this talk, which is around scale-free networks. I'll just do this from now on. Great. This kind of homogeneous application architecture and heterogeneous deployment or heterogeneous trust models is also incredibly scalable. Because state should be co-located only and only if it's valuable together. There's absolutely 0 point in co-locating all, for example, transactions happening in Bangkok with all transactions happening in Zurich. If they do not touch the same piece of global state, why are we putting them into the same synchronous global consensus lock? We're just paying now to like keep a bunch of state in global consensus. We're taking a bunch of latency hits. So state should only be co-located together when it's valuable. And generally, this means when it's culturally close. As in, and I say culturally close here because the World of Warcraft community has a bunch of state that is valuable next to each other. The Ethereum community, we have a bunch of state that's valuable next to each other. Someone doing random payments is not valuable next to World of Warcraft or Ethereum state. This is like, you want to have the ability to have very fine-grained control over where state lives and on what security model state lives, because it's going to be much cheaper. Incidentally, it's also going to be much faster. By co-locating only the state that you actually need, for example, if we only in this room want to trade, the single fastest and most optimized way to do this is to do local area networking. Solana will never beat this unless they can violate the laws of physics. Like if we want to get if you have latency critical applications, it makes sense that you are directly connected to each other. And this really comes down to physical proximity, because global connectivity is not all that fast. It's maybe something like probably 500 milliseconds or so if you're fast. So you should be able to only opt in to also co-locating state when you actually want to pay for this. For example, if you want to execute a block trade between Zurich and London, for example, between two parts of state that actually like, you want to have an atomic update on, but that live on two separate systems, then you should just be able to opt in to update, to like co-locate these two pieces of state. You shouldn't have to force everyone to be co-located with each other. And then users and application can actually start roaming between instances here. The interesting thing is what happens when you start thinking of users as their own state controllers. So state is always created by someone. For example, Circle, as in USDC, they are a 1 out of 1 blockchain. And really the easiest mental model to think of Circle is a 1 out of 1 blockchain that is backed by a single key that sort of gives updates to everyone signed by their key. And they create USDC, right? Ethereum creates ETH. No one else can inflate the supply of ETH but Ethereum. And so you always then start thinking, well, if I create my own token, so if I have admin power over some sort of asset that I issue, it would make a lot more sense if it's running on my 1 out of 1 blockchain than I'm delegating this to some other external system where I still maintain admin control. So every community can co-locate their personal state. And as a result, single instances only need to handle sort of the maximum state/user throughput of that community. You can then turn this into an on-demand chartered system if you're actually interested in the consensus research behind this. There is a bunch of papers around Typhon, and I really mean Typhon because I thought that's the way you pronounce typhoon. So it's called Typhon now, and also, it's pronounced Typhon. And yeah, we had the example of the block trade between two stock exchanges. Yeah, this is actually also the other reason why this is super scalable is because when you think of the routing problem of if every instance, if every chain is the control of its own state, it makes a lot more sense to route via the chains that create the state. So for example, if I would like to move some ETH from Optimism to Arbitrum, I should obviously route this via Ethereum. If I route this via a third party, it makes absolutely no sense. So as a result, like if you want to route USDC from chain A to chain B, you should always route this via Circle directly, because it's like the least trusted way to do this, because you trust Circle anyway to do it. It's also going to be the cheapest because Circle needs to update its state anyway. And the super nice part of this, it gets rid of one of the weirdest abstractions we have in the space, which is between users and chains. Because right now there's a user, and the user must run some full node or must connect to some other external full node and issue RPC requests against this. It is much clearer if we think of users as one-on-one blockchains that have limited state. They only have state that is relevant to that user. All of a sudden, we're building exactly the same networking stacks, the same interoperability stacks that allows users to move some assets between them and Ethereum, and them, Ethereum, and Optimism. It's like we just get this very nice homogeneous architecture where we don't have to jump these weird abstraction barriers, which we currently have to do. Yeah, and I gave the example of asset routing. Yeah. The last part is, the goal of the space is to build World War III resilient infrastructure. And I'm using this very extreme example of World War III resilience because I think it is not because we should be hoping for this. This would be very messy and we should all pray that this doesn't happen, but it gives us the right frame of mind to actually design resilient infrastructure because it's a very specific sort of like threat model. So, fundamentally, we need to provide a replacement upgrade for existing coordination infrastructure. We have historically lived, pretty much the internet has lived in this very happy Pax Americana galore, and none of this infrastructure was designed with large-scale adversaries, large-scale nation-state adversaries in mind. Living in Switzerland, I think I can confidently say that the Swiss financial system will not survive a dedicated onslaught by any sort of nation-state actor, because it was never designed to be actually resilient. Because when the internet came about, it was sort of like, oh, this is this very nice thing, everyone is very friendly with each other, and we didn't really design this in mind with having large-scale, like having critical infrastructure on it. On day one of World War III, global connectivity is immediately gone. I gave the reason sort of why earlier on. And this fundamentally means that things like Visa and MasterCard will just stop working because they, to a large extent, rely on global consensus. I mean, not global decentralized consensus, but some amount of servers being accessible in the US, for example. This is also the reason why I find the moves that Sweden and Norway are making with regards to cashless society is quite brave. If you're going for a cashless society, you better fucking be sure that your financial infrastructure is actually resilient in sort of the future. Because the future is going to be more unstable than the present. And I think like we're heading in this into this multipolar world order where things will just get messy and more complicated. And we need to be designing our infrastructure for this case. As a result, we also need privacy. But here, I would really urge people to think of privacy not as something where you are fighting the government, or it's privacy for national defense, or privacy for community defense. I think a lot of the reasons why people think of privacy to be against the government is because they secretly don't, or openly don't like the government. But like, this is not really, like if you don't like your local jurisdiction, move, vote with your feet, right? Like, or try to change it locally on the ground. But really think of this, that Switzerland, the country, has a vested interest in its financial data not being leaked to North Korea. Like, I think the quickest way to shut down global Ethereum tomorrow is to move all the US financial system to global Ethereum today. And like in a day or two, the NSA will go, that's probably a bad idea. Why did we make our entire financial system readable by the world, including every foreign power? So really think of privacy not as something that, like, think of privacy as something that every community will want. Because in order to have stable communities, you need stable financial privacy. Like, my parents will never want to adopt a system that leaks all the data either to the neighbor or the North Koreans, really. But I think privacy for national defense is a much more sort of positive framing of the problem than like you want to hide your financial information from the tax authorities. And the nice thing is, in the best case, like when I think of world resilient infrastructure, it's a little bit about, in the best case, we never need this infrastructure. In the best case, we always maintain global connectivity. But in the worst case, we want to have infrastructure that is capable of running as local as required, but as global as possible. And this really means, for example, if something happened to all connectivity outside of this room, it'd still be nice to be able to run coordination infrastructure that is local to this room, run on like the computer hardware that we have in this room. And this is technically completely feasible if we design our systems and architectures around this. Yes, so fundamentally coordination protocols, i.e. blockchains, can interoperate as much as the physical network allows. If you have global connectivity, you can do global connectivity stuff and you can like rely on global consensus. If you only have local connectivity, you can only do local things. But you want to allow the systems to gracefully degrade and upgrade again. So that if you go from global connectivity to only local connectivity, you can still make state updates over your local state, and then as you recover, you can reach out into the global system again. Yeah, and scale-free networks are all about being as local as required or as global as possible. And I'll use the second example of the Swiss here, mostly because the Swiss are paranoid. And the Swiss have been paranoid way longer than our space has been around. So I think to some extent we should be learning from them a little bit. And once in a blue moon when I moved to Zug, I was like, oh, I should get involved in the local community, and I looked up the ham radio club of Zug. And so you go to the website of the local ham radio club, and then you click around the website a little bit, and then you come across the charter given to them by the canton of Zug, which effectively states that the local ham radio club is responsible to get emergency backup comms online within 6 hours of a national disaster. And the entire idea is that the local ham radio club has volunteers that have cars with backup generators and antennas, and when shit hits the fan and you lose sort of connectivity, they will drive them up to the mountain peaks around the canton, 3 minutes, great, I'm almost done, and restore backup comms for emergency services. And this is the kind of thing we should be thinking about. Like, if we actually want to have resilient infrastructure, we need to be thinking like, how do we actually build these resilient systems? And I know this talk isn't for those in the audience that like meme coin trading, and like this is much more sort of like, to some extent, depressing, but also I think this is where the real value from the space comes from. Like, the real value is not the meme coin casino, the real value is the resilient infrastructure that we can build along the way. Yeah. Oh, this is maybe the really last important point. If you're in this room, you're most likely in charge. I.e., you're in charge to provide local infrastructure to your local community. And this starts with very basic things such as, please run your own Ethereum nodes. If you're in this room and you're technical and you're not running your own Ethereum nodes, like, we're doing something wrong in the space. Like, everyone should be running their own Ethereum nodes, everyone should be running their own Uniswap front ends. There's really, like, if you are reliant on Infura being online or on uniswap.org not being compromised, this is a bad setup, and we like should be practicing the things we preach. And yeah, for your local community, you are most likely the guy in charge. Because like my parents will not figure out how to install a new application on their phone or how to run an Ethereum node, but someone in their community will, right? Like, it's not that everyone needs to be completely self-sufficient. Generally speaking, societies don't work this way. There's like some division of labor, and you want to allow, like, we are in this room are the people that have to rack up a bunch of hacky hardware to make local consensus work again. Yeah. So, quick TLDR. Single decentralized networks are still centralized. A single global security model is fucking terrifying, and please let's not sort of backdoor our way to a one world government, because we don't like it for many valid reasons. Different users have fundamentally different preferences for their own security, and we need many independent security models in order to allow people to have a credible threat of an exit. Fundamentally, when building these systems, we should be thinking about how do we build scale-free networks, i.e. things that scale very easily because we aren't designing bottlenecks into them. And like, for example, in the asset routing example, if there would be a single chain to route all assets, that'd be a very bad idea because that single chain is now a scaling bottleneck. So you want to really design these kind of scale-free protocols and architectures in order to get there. Yeah, you should have applications that are capable of roaming, privacy really matters, and please run your own nodes. Honestly, if you only remember like one thing from this talk, go home and set up your own local infrastructure. It's not hard. A single Raspberry Pi is all you need. Like, single Raspberry Pi and a 4 terabyte USB drive, and you're good to go to run like all infrastructure you will probably need in the next year. And if you don't know how, there are many people today and also the rest of the week that will gladly teach you how to do it. And I'm saying this from a very personal thing, like the way I got involved in Ethereum in 2016 was at meetups, people would teach you how to install your own Ethereum node and run your own Ethereum node before you could make a single transaction. Like the first thing you did was like install Ethereum, run the node, sync the network, and only after you managed to sync the network, you could start actually using Ethereum. It was great. I think. Yeah, we should also learn a little bit from the internet. The internet was actually designed quite well, and yeah, the goal of the space is to be built with resilient infrastructure. Thank you very much.